Hey there, Math 1. So welcome to day number 2 of my time in quarantine here. Today we are going to continue chapter 6 and we are going to learn a new way to solve a system of equations. So let's get started. Alright, so before we do any notes, I just want to remind you of what you should know how to do already. Right? So a system of equations is like two equations with two variables. And your goal is to find an ordered pair, an x value and a y value, that works for both equations at the same time. In this example, it might be x equals 6, y equals 4. Oops. Because 6 plus 4 is 10 and 6 minus 4 is 2. Right? So the question is, how do we find that ordered pair? And so far you have found it two different ways. You have found it by taking these two equations and graphing them. Might look like that. And the point where they cross, that would be your solution. Any point where they intersect. And we have also learned how to take these two equations and use what we called substitution to get the same answer. Right? And today we're going to learn a new method. It is my favorite method. And you're going to need a sheet of notebook paper to do this on. So I did not give you guided notes, but there's not going to be that many notes. It'll be okay. You can do it on the notebook paper. And here we go. So at the top of your paper, I would like you to put notes. And this will be section 6.3. All right. So, in the last section, we had equations that already had a variable by itself. That might look like y equals mx plus b. You all should be familiar with that. That is known as slope-intercept form. And when you have an equation in slope-intercept form, it probably works better to graph it or to use the substitution method. Today, we're going to look at equations that look more like this. This is actually known as standard form. Didn't write that very well. Standard form looks like ax plus by equals c, where you have like your x term and your y term equals some number. Unlike slope-intercept form, there's no real meaning, like this is the slope and this is the y-intercept. The a, b, and c don't really have a meaning, other than the a is the coefficient of x, the b is the coefficient of y, and the c is just a number. So like in this example, a would be 2, b would be 3, c would be negative 10. And when equations are written in standard form, there is a better way typically to solve the system of equations. And that is known as the elimination method. And that is what we're going to learn today. Well, the elimination method has a goal. We're going to write that goal out first. It is to add the equations together so that one of the variables cancels out. And you'll see if one of the variables cancels out, it gets really easy to solve. Let me show you a quick example that this happens beautifully. 2x plus 5y equals 17. And 6x minus 5y equals negative 9. So if I had these two equations in standard form, right, they're both in ax plus by equals c form, I could go ahead and add them together, and I would get 8x when I add the 2x and the 6x, but look at the y's. The y's are opposites of each other. And when you add opposites of each other together, they just cancel out. They'd be 0 times y, or just 0. And this would equal 8. I end up with 8x equals 8. And we all know how to solve that immediately in our head. All right, we would divide by 8, and we would get x equals 1. And once I have x equals 1, I could take this top equation, and I could put the 1 in for the x, and I could say 2 times 1 plus 5y equals 17. Of course, 2 times 1 is 2, so I'd have 2 plus 5y equals 17. And if I subtract 2 from both sides, and then I divide by 5, I get y equals 3, and I have solved the system of equations. All right, by adding them together and eliminating, right, that's why it's called the elimination method. When you add the equations together, one of the variables gets eliminated. Well, I got to tell you, it's not always that easy. It's not always that easy because you don't always have opposites for one of the variables. But we can make that happen. So these might be your steps to solving a system of equations. All right, step 1, multiply 1, and in parentheses, or both, multiply one or both equations by something so that you make opposites. And in parentheses I put of either x's or y's. This, you guys, is the key step in solving the system by the elimination method. Multiplying the equation by something so that you make opposites. And from there on, you're good to go probably. Then, add the equations together. Right? Add the equations together. Solve for the remaining, holy cow, variable, nice G there, remaining. Then, sub your answer back into any equation and solve for the other variable. Alright, sub your answer back into any equation and solve for the other variable, and you're done. Let me do 2 examples, and we will call it a day on this. So the first example is going to be, we'll call this example 1, is going to be negative 2x plus 15y equals negative 32. And the other one will be 7x minus 5y equals 17. Notice that I like to stack my 2 equations on top of each other so everything lines up, as opposed to the substitution method where I wrote them side by side. All right, so my job, the key step here, is this step 1. There it is. Multiply one or both equations by something so that you make opposites. It doesn't matter whether you make the x's into opposites or the y's. You want to choose the one that's easier. And in this case, I think the y's look easier. One of them is a 15 and one of them is a 5. So I could easily turn that 5 into a 15 and I would have opposites. Now, I also want them to be opposite signs, which they already are. So all I need to do is multiply this bottom equation by 3, and I will have a negative 15 here, and I will have my opposites. So I usually make these little arrows, not that important. And I go ahead and, in this case, the top equation does not need multiplied by anything, so I'm just going to rewrite it. Negative 2x plus 15y equals negative 32. But the bottom equation I'm multiplying by 3. And the biggest mistake I see people make is they forget to multiply everything by 3. 3 times 7x gives me 21x. 3 times negative 5y gives me negative 15y. And 3 times 17 gives me 51. I'm now ready to add my equations together. This is step 2. Look, I've made my opposites, 15y and negative 15y. So now I can add the x's together and get 19x. I can add the numbers together and get 19. Easy to solve, right? Divide both sides by 19, you get x equals 1. So then the last step is take my answer and put it back into whatever equation you think looks the easiest. I guess I feel like the easiest one is going to be this second one. So I'm going to put 1 in place of the x. That'd be 7 times 1 minus 5y equals 17. Well, 7 times 1 is just 7. So I'm going to subtract 7 from both sides, get negative 5y equals 10, divide by negative 5, and I get y equals negative 2. And I have solved my system of equations. X equals 1, y equals negative 2. If they want me to write this as an ordered pair, it would be 1, negative 2. All right, one more an example, and we will call it a day. Example 2. My example 2 is going to be 3x plus 2y equals 1, and 4x plus 3y equals negative 2. So I have a choice now. I can either turn the x's into the same number. Looks like that a good number would be, let's see, a number those both go into. That'd be 12. I could make these both 12s, but I would make them opposites. Or I could make these both something they go into. They both go into 6. And since 6 is smaller, I'm going to choose the y's. So I'm going to make both these guys into 6's. The top one would need multiplied by 3. The bottom one, now I want this to be, this top one's going to be a positive 6. So I want this bottom one to be a negative 6. So I'm going to multiply down here by negative 2. And this is fairly easy to do, right? 3 times the 3 gives me 9x. 3 times the 2 gives me 6y. And 3 times the 1 gives me 3. And on the bottom, I have the negative 2 times the 4 gives me negative 8. Negative 2 times the positive 3 gives me negative 6y. And negative 2 times negative 2 gives me a positive 4. Again, I have made the y's into opposites, but I could have done the x's. I am ready to add these together. 9x and minus 8x would just be x. Well, that's beautiful. 3 and 4 gives me 7. I've already got my x value. X equals 7. Then the last step is to take that and substitute it in. I'm going to put it in the first equation. So I would have 3 times 7 plus 2y equals 1. That would be 21 plus 2y equals 1 when I multiply the 3 and the 7. I would subtract the 21 and get 2y equals negative 20. And finally, I would divide by 2 and get y equals negative 10. So again, I have found my solution. It's x equals 7, y equals negative 10. Or as an ordered pair, that would be 7, negative 10. So we'll practice a few of these on Delta Math along with a couple of the reviews from the other types. And we'll be done. Have a great weekend. See ya.